All right, class, let's get right into it, right? This is 3 day two, not really day 2. We'll call it part 2, okay? And we learned some very important rules of differentiation right here, okay? And this kind of teaches us what this first one is about. Okay, let's take the derivative if I'm multiplying two quantities like that. Well, going back to please excuse my dear Aunt Sally, right, we would do our parentheses first. And I would simplify to get 3x cubed. Now that 3 is a constant, remember, we could bring that out, or I could just simply drop that 3 and we get 9x squared. Okay, that is 100% legit. Why? Because I used my PEMDAS old school rules. Now, would it work if I kind of split them up? Remember, for addition and subtraction, we could split those guys up. Can I do that for multiplication? Let's check. If I can, I'll get the same answer. The derivative of x squared is 2x, and let's multiply that by the derivative of 3x, which is 3, and I get an answer of 6x. Did I get the same answer? No way, Jose. So you cannot do it. Okay, we cannot distribute that derivative function in like that. Okay, so there has to be another way to maybe deal with situations like this, and that's what we get into right now. Before we actually dive into it, we are going to look at kind of a word problem here. Okay, the volume of a cube with sides of length f is given by this function. Find dv ds when s is equal to 4 centimeters, and tell me what the heck this bad boy right here means. Okay, so first let's find the derivative of v with respect to s, which would simply be the derivative of v, which happens to be s cubed with respect to s. So that'd be a little 3s squared. Okay, that's the derivative. Now, notationally, we always want to be able to write things correctly. And if I use this dv over ds notation, I do that little cool bar. I do a little s is equal to 4, which means I'm putting a 4 in for s, and I get 3 times 4 squared. That'd be 16 times 3, which is 48. What the heck does that mean? Okay, what does that mean? Now, a couple of things. V is volume. Okay, V is volume. So a volume would be centimeters cubed, right? So I'm already helping out my answer with the units. So that'd be centimeters cubed per s. Okay, what does s stand for? Okay, and that would be my sides. Now, what's my sides here? That would be centimeters. Okay, that'd be the units of the sides. All right, so what the heck does that mean? And I want you guys to write this down. Okay, I'm not going to write it all down there in case this pen goes off again. But the volume of the cube, remember, a derivative is a rate, is increasing at a rate of 48 cubic centimeters per centimeter. That's what it's increasing at in terms of when the side length is 4 centimeters. Okay, so the volume of the cube is increasing at a rate of 48 cubic centimeters per centimeter when the side is 4 centimeters in length. Okay, hit pause, take a look at that. Just a little bit of a word problem and how we interpret it. But now let's get to the nuts and bolts here of our rules and the biggest rules that we are going to be dealing with in Chapter 3, the product rule. Okay, and here we go. The product rule. To understand what the product rule is about, we're going to look at this guy right here. And we're going to do it how we would solve this if we didn't know the product rule. Now, if we didn't know the product rule, we would go ahead and do a little first, inside, outside, last. And I kind of have this simplified already. So if I did that, I would get 15x to the third minus 21 plus 10x to the 7 halves minus 14x to the 1 half. Okay, that's just foiling that bad boy out, doing my little distributive property. Now when I do the derivative, I get 45x squared. That 21, right, class, goes away. I get plus, let's drop that 7 halves down. If I drop that 7 halves down, I get 70 over 2. 70 over 2 is 35x. I have to subtract 1. So 7 halves minus 2 over 2 is 5 over 2. Minus, drop that half down, 14 becomes a 7x to the negative 1 half. That is 100% legit. That is good to go. Okay, but if you notice at the beginning of the problem, that is a product, which thus means I could use what we call the product rule. Okay, and most books have this definition, so I'm going to use it this year. Okay, so how the heck do I do this problem using the product rule? Well, we're gonna say that u is equal to 3 plus 2x to the 1 half. okay? And we're going to say v is equal to 5x to the third minus 7. That's 7 in French. And we're going to take the derivative now. Okay, so I can still call it y prime, but let's get after it. Okay, now what does this product rule say? It says u. So we're just going to rewrite u. 3 plus 2x to the 1/2. Okay? And I'm going to multiply that by the derivative of v. And the derivative of v with respect to x would be 15x squared. Okay? And then whenever we do the product rule, it's separated the two quantities by a plus sign. Okay, and the second half says we're going to rewrite down v. Well, what's v? Oh, snap. Don't run out of room, Mr. T. Okay, it's 5x cubed plus 7. And we're going to multiply that guy by the derivative of u, which would be, ooh, let's drop that guy. Oh, sweet, it goes away. And I get x to the negative 1/2. Now, is my problem done? No way, Jose. I just got to do a little bit distributing in here. Let's see what we get. We get 45x squared plus 30. Ooh. I've got little exponents here I got to deal with. How do I deal with exponents when we multiply? Do we remember, class? Some of you guys forget. But remember, when we multiply, we add. So that'd be like a 4/2. So that'd be x to the 5/2 right there. Right, class? Okay? And then let's keep on going. Let's keep on rolling. And then we go ahead and we distribute that bad boy in, and I get a minus 5x. Oh, snap. I've got to add those guys together. What do I get when I get that? Well, 3 is 6/2. So if I have a 6/2 and a negative 1/2, that gives me a 5/2. Right, class? Ooh, minus. You guys are probably saying, what's up? That's got to be a plus. And then we have plus 7x to the negative 1/2. And then guess what? I can combine those bad boys, and oh, you've got, ooh. I should have a minus sign somewhere, class. Where was it? Oh, there it is. My apologies. That's a minus. That's a minus. So I should get the same exact answer when I combine those two guys together. And that's an example of the product rule. Now, some of you are saying, Mr. T, this side was way more work than this side over here. And you're 100% correct. If I had this problem on a test or quiz, I would distribute and then do it. Okay, but what you guys are going to find out when we start dealing with like trig functions and some e functions and some logs and some exponentials, oh my goodness, I better know this product rule. Okay, you guys? So yes, this way looks like it's way longer, but we're going to do the product rule quite a bit in AP Calc. All right, let's roll. Quotient rule. Okay, quotient rule gets a little bit difficulty. I've never been a fan of this saying, but we're doing it this year because every year you guys like it. Okay, so we have our little formula up here. We can get a little bit lost in there. So some really smart teacher way back in the day, I'm not smart enough and I don't like Seven Dwarfs or whatever it is, Sleeping Beauty or whatever this thing came from. But it's a little low D high minus high D low over low low. And if you start using this thing, you're going to end up getting really good at it. Okay? Now, let's say this was my problem initially. I could do this one two ways. I would never want to do the quotient rule. But we like to do this when we're first teaching it so you can understand why it works. What would I do in that case? Well, I would simplify that bad boy first, right, class? What would that be? That'd be 6 over x or 6x to the negative 1, right, class? Okay, and then we do a little power rule. What's my power rule? Negative 6x to the negative 10. Booyah, I am done. Why would you ever use this guy? Okay, but let's do it. Let's see what this bad boy is about. Okay, so here we go. Low. Now circle it while I'm using it. Low means you rewrite the low dude. Okay, so let's rewrite this real nice and pretty. 6x over x squared. Okay, low. Let's rewrite the low guy. Then I'm going to take the derivative of the high. And the derivative of 6x is 6. And then it's always a minus sign when we do the quotient rule. And then it's high. Okay, so it just means I'm going to rewrite down the high. And I'm going to take the derivative of the low. The derivative of this low is 2x. You guys with me? And that is all over low, low. So it's x squared times x squared. Sorry, I'm working on that writing. Now, how the heck do I get that as my answer? Well, maybe it works out. Let's check this out. We get 6x squared minus 12x squared all over low, which would be x to the fourth. What the heck does that give me? Well, that gives me a negative 6x squared over x. Oh, no way. Negative 6 over x squared. Oh, that's the same thing. Crazy. And yes, you're correct. If I ever gave this bad boy to you on a test, you better always do it the shortcut way. But what do you do if we have a problem like our next one? Okay? Where it's written like so. You kind of have to do it using low D high minus high D low over low. All right, challenge yourself, please. Hit that pause button, see if you can get this, okay? I'm going to actually get started right now, so I hope you hit the pause button. All right, so let's take the derivative of that bad boy. That's a quotient rule. Okay, why? Because I have that binomial upstairs. I got, right, that's a rational function, right? Class polynomial over polynomial. All right, let's do this one. Low, which means you just rewrite the low, times the derivative of the high, which is 10x, minus the high, which is 5x squared, times the derivative of the low, which would be 3x squared, right, in class? And that's all over low. And guess what? I'm really nice on these problems. Very rarely am I ever going to make you simplify that bottom, okay? But you always have to simplify the top. So we just got to do a little, show off our distributing skills. Minus 15x to the fourth over x to the third plus 1 squared, which is equal to, what would that be? Negative 5x to the fourth plus 10x all over x cubed plus 1. You do not have to FOIL out the bottom. Don't factor anything out of the top. That bad boy is done. Okay? Once again, we're going to go to 16. I challenge you to hit that pause button, and I think that says the second derivative. Oh my gosh, so fun. I get to do this 2 times. All right, let's go. F prime of x. Let's do a little low D high. The low times the derivative of the high. Derivative of x is 1. Minus the high times the derivative of the low. The derivative of x minus 1 would just be 1. All over low. X minus 1 times x minus 1 is x minus 1 squared. Always simplify. Okay, so let's simplify that. Top, x minus 1 minus x all over x minus 1 quantity squared, which would be snap, which would be negative 1. Oh, since I've got to go another time, I've got to FOIL this out, which would be x squared minus 2x plus 1. Right, class? Because they're asking me to find the second derivative. Sweet, I get to do this again. Here we go. Low x squared minus 2x plus 1 times the derivative of the high. Oh my gosh, it's a negative 1. Sweet. If I multiply it by 0, it all goes away. Minus, ooh, am I running out of room? I hope not. The high, which is negative 1, times the derivative of the low, which what would that guy be? That'd be a couple power rules, or 2x minus 2. And that is all over. And since this is the last one I have to do, thank goodness, I can just write low as the low squared. I do have to simplify the top, but sweet. Ooh, that's 2 negatives there. So I'm going to end up with a positive. So the same thing. And that, believe it or not, is my answer. Not too bad. Hopefully you tried it on your own. Hopefully you got it right in case we have a pop quiz tomorrow. Aloha, class. Make sure, keep up with these worksheets. If you ever want to borrow a book from me, come and see me, borrow a book. I have a whole bunch of extra problems. Another good outlet is, hey, all you have to do is Google AP Calculus product rule, AP Calculus quotient rule. But remember, right now we can kind of only do it with polynomials, okay? You guys, it gets really fun when we get some trig in there, some natural logs in that bad boy, some power functions in there. See ya. Aloha.